Okay, welcome to problem set 28. We've just got a couple more homeworks after this. Almost done. This one is on some conic sections, so like parabolas, ellipses. I don't think there's anything on hyperbolas in this one. I believe hyperbolas are touched on more in the next homework. So let's take a look at number 1. It says the vertex of a parabola is 5, 0, and the directrix is at x equals 0. So we first want to find which form does the equation of the given parabola fit. So which of these two? Well, if we've been looking at our textbook and whatnot, then we know that this form has the focus, but it has the directrix of y equals something, whereas this form has a directrix of x equals something. So since our directrix is x equals 0, we know that it's going to be this one. Actually use a different color for that. Okay, and now we want to actually write the equation for that parabola and sketch out what that's going to look like. So because this is this form, that directrix is x equals 0, that tells me it's going to be a horizontal parabola, which means instead of looking something like this or like this, it's instead going to be like that, or perhaps even that way. We'll see as we work this out. So it says first that our vertex is 5, 0, and we know the directrix is x equals 0. What we need to find from there is going to be that c value. So first of all, since we know our vertex, we can plug that into there. So now instead of y minus k, it's going to be y minus 0, or just y. So it's going to be y squared equals 4 times c times x minus h. So it's going to be x minus 5. Okay? And as of right now, the only value we know for sure is that vertex. So plugging things in isn't going to help us a lot. Let's see. It would be helpful to find our focus, because our focus typically tells us that c value, as does the directrix, however. Let's see. So if we were to sketch this so far, let's see, we know it's 5, 0, so let's say that's 5. We know that there's our vertex. I'm trying to remember what the next step is, because it keeps slipping my mind. Right, so this is just something we have to memorize, which is why it's so tough for me to remember it right now. Our c value is typically going to be the x coordinate of the vertex. So the x coordinate of the vertex, in this case 5, minus the directrix, which is in this case 0. So it's going to be 5 minus 0, or just 5. So if c equals 5, that makes our equation y squared equals 4 times 5, or 20, x minus 5. Now in the homework, you just need to do the vertex and then one of the points. So I think that's probably how we'll sketch this out. So let's try if I plug in maybe 6, right? Oops. So if I plug in x equals 6, it's going to be y squared equals 20 times 1. So it means y squared equals 20. Y equals plus or minus the square root of 20, which is, I could also simplify that to plus or minus 2 square roots of 5, which is, of course, there's the plus and there's the minus. I don't know exactly where those fall, but it gives us a good idea that it's going to look something like that. On to number 2. It says a parabola is a collection of points whose distance from this point is the same as the distance from this line. And we want to figure out what the equation is and sketch it. So what this tells us, if they're the same distance from this point as they are from that line, that tells me that this is our focus and directrix. Because the focus and the directrix, the points on a parabola is always going to be the same distance from the focus as it is from the directrix. So if our focus is 2, 5, and our directrix is y equals -1. Well, first of all, the format of our directrix tells us which equation we want to use. It means we're going to use this one, right, because it's that y equals. So I know it's going to be x minus h squared equals 4 times c times y minus k. But we don't know our vertex yet, so this becomes tricky. Let's go ahead and draw what we do know, though, which is that this line, y equals -1, is going to be the same distance from our parabola as this point, 2, 5. Okay? And if it's going to be the same distance, then I know at this point, at x equals 2, I know that it's going to be right smack dab between them. So the distance between them, of course, is going to be subtracting those y values. So it's 5 minus -1. So this is a distance of 6. So this is a distance of 3, which means that this is right at y equals 2. Which that's going to be my vertex because our focus is always lined up with our vertex. So our vertex is 2, 2. So I can go ahead and plug that in. So x minus 2 squared equals 4 times c times y minus 2. And now we're getting somewhere. Now all we have to do is figure out that c value and then sketch another point on our graph. Of course, this is going to be a parabola that looks something like that. Let's see, how do we find that c value now? Well, we could do what we did before, where c equals that x coordinate, which is 2, minus our directrix. So c is going to be 3, because it's going to be 2 minus -1, or just 2 plus 1. If c equals 3, then our equation is going to be x minus 2 squared equals 12 y minus 2. And now let's just try plugging in another point. Let's say 4, and that's going to be 2 squared, because 4 minus 2 equals 12 times 2. So, we don't know our y value there, so it's going to be 12 times y minus 2. I was just thinking the wrong thing. So 4 equals 12 times y minus 2. Divide both sides by 12. That's going to be 1/3 equals y minus 2. Y equals 2 and 1/3. It's going to look something like that, which means our parabola is going to look something like that. And hopefully this is making sense. I know conic sections aren't really something most of us have done since like pre-calc, which means I haven't done it since I was a sophomore in high school. Jesus. But number 3, I'm going to erase this so we've got space for number 3. So number 3 says the foci of an ellipse are plus or minus 4, 0, and the vertices are plus or minus 6, 0. Find the equation of the ellipse and determine its radii. So this is an ellipse, so it's obviously going to be a different equation than before. And so the equation of an ellipse is going to be x minus h squared over some radius squared plus y minus k squared over some other radius squared, all equals 1. Okay, let's go from here. It says my foci. Oh, we've got our vertices. where that's our y is 0, and our h is going to be 6 there. So it's going to be x minus 6 squared plus y squared equals 1. Good. And now, from here, let's see. To find the focus of an ellipse, we typically say that our focus squared is equal to the major, so I don't actually, oh yes I do. It's equal to the radius of the major axis squared minus the radius of the minor axis squared. So in this case, I know that my major axis is my x-axis because my foci is along the x-axis, so that's why my a squared and b squared are there. If my y-axis was my major axis, I would just flip those two. But so I know that c equals 4 in this case, so c squared is going to be 16 equals a squared minus b squared. But we still don't know. Sorry. I'm still a little tired. It's pretty early morning. Remember that if we have an ellipse, right, in this case, since our major axis is the x-axis, it's going to be an ellipse that looks something like this. In this case, it looks like so sorry. Those are our vertices, and I tried to write the center. Our vertices are both plus or minus 6, so that is negative 6, 0, positive 6, 0. That's what that looks like, which means that our center is going to be at the origin. So it should be like that. I am so sorry, you guys. I got totally mixed up for a minute there. And so this radius, a, equals 6, which means that a squared is going to be 36, so it's going to be x squared over 36 plus whatever this radius b is. We don't know that yet, but we do know our focus, and we know that first a value. So now we can do that c squared equals a squared minus b squared. And remember, this is minus, of course, our Pythagorean theorem, and we use a Pythagorean theorem for finding the foci of a hyperbola, but for an ellipse, we're subtracting. So be careful not to mix that up. But then from here, I know c squared is 4, so it's 16 equals 36 minus b squared, which, just looking at this, tells me b squared must equal 20. So b is going to be plus or minus the square root of 20. But I can just plug in 20 there. So our equation is going to be x squared over 36 plus y squared over 20 equals 1. And it has radii of 6 and square root of 20. Okay. Looking at number 4, it says an ellipse passes through the points 1, 1/2 and -1/2, -1, and is in standard position, which means that it is centered about origin. We want to find the equation of the ellipse, so it's 1 equals something. So standard position means that it's centered at origin, which means it's just going to be x squared over some radius plus y squared over some radius equals 1. What we have to do here is we're going to plug in both of these points. I'm going to plug in this one first. So x is 1, so it's 1 squared, which is 1 over a squared, plus 1/2 squared is 1/4, and I can just move that 4 into the denominator because it's 1/4 over b squared, or 1/4 1 over 4b squared equals 1. And so that's this first one. And then the second one is going to be over here. So I'm going to do that same thing. Plus 1 over b squared equals 1. And now because these are both equal to 1, I can set this equal to this, because they should be equal. based on what we just found. So I'm going to set them equal to each other, and I'm going to try to get one of these variables in terms of the other. And you'll see what I mean as I do this. So first, of course, we want to combine these fractions to find common denominator, which is going to turn it into, let's see, it's going to be 4b squared plus a squared all over 4a squared b squared is equal to b squared plus 4a squared over 4a squared b squared. Now our denominators are the same, so I can cancel those out, which you could also do through cross multiplication, but it's just easier to cross it out, which tells me that 4b squared plus a squared equals b squared plus 4a squared. Now I'm going to subtract a squared from both sides and subtract b squared from both sides, so I'm going to get 3b squared equals 3a squared, which then, of course, dividing off the 3's, we get b squared equals a squared. Knowing that now, I can come back to these equations up here. I'm going to pick this one, and I'm going to plug in my a squared for that b squared. So it's going to be 1 over a squared plus 1 over 4a squared equals 1. And this is the same thing, right? Because we found that those are equal. And I'm actually going to just circle that really quick. Now, I'm going to use this to solve for a. So again, find that common denominator by cross multiplying. So it's going to be 4a squared plus a squared equals 4a to the fourth, over 4a to the fourth equals 1. And then, of course, that's going to combine to be 5a squared over 4a to the fourth equals 1, which I then get, cancel off that, so it's going to be 5 over 4a squared equals 1, and then I'll multiply both sides by a squared, so 5/4 equals a squared, right, because it's going to cancel, and so a equals plus or minus square root 5/4. So I know now that a squared equals 5/4, which since b squared equals a squared, b squared must also equal 5/4. And knowing that, we can then plug into our equation. Again, we know it's x squared and y squared because it's centered at 0. So it's going to be x squared over 5/4, which I could write as 4x squared over 5, plus y squared over 5/4, or 4y squared over 5, all equal to 1. There we go. Taking a look now at number 5, we're given this equation here, so it's 2x squared plus 5y squared equals 1. And first we have to figure out what type of conic section that is. So is it a parabola? Is it a hyperbola? Is it an ellipse? And looking at this, that looks like that's going to be an ellipse, because remember our equation for a parabola only had one of our terms squared, not both of them. So looking at this looks like it's an ellipse, but where are our radii, right? Well, that just means that this is x squared over 1/2, right? Because 2x squared equals x squared over 1/2, because we'd flip that fraction. And this is y squared equals y squared over 1/5, which tells me that this radius is the square root of 1/2, and this radius is the square root of 1/5. So, well, that's not super helpful there, but it does help us find our vertices. So this looks like it's centered about origin. So we're going to have, actually, we'll sketch this out a little. So it's centered at origin, there's its center. And I know this radius, I'll call this a. So a squared equals 1/2, which means a equals plus or minus 1 over the square root of 2. And then b squared equals 1/5. So b equals plus or minus 1 over the square root of 5. Those are not my favorite numbers to work with, but we will do our best. So if it's centered here, if this is obviously bigger than this, so my x-axis is my major axis, which I actually can write down here. So major axis is my x-axis, or y equals 0. Now, right now we're looking for those vertices, although we could do the foci, but I'm going to look for the vertices right now. So I know my major axis, it's going to be that x value plus or minus that first radius. So it's x, so it's 0 plus 1 over the square root of 2, which is going to be, I'm going to say that that's 1, a negative 1, and don't expect this to be perfectly to scale, because I'm just kind of doing this to help myself. So we'll say that that's 1 over square root of 2, 1 over square root of 3, 1 over square root of 4, 1 over square root of 5, and just kind of like that. And that's almost certainly not to scale, but just to have those spots. So that tells me, well, that's not actually super necessary. Undo that, actually. I know that 1 over the square root of 2 is going to be a little bit less than 1, but a little bit bigger than 1/2, obviously. So I know it's going to be somewhere in here is that vertice, and somewhere in there. And then my vertices on my minor axis, which is my y-axis here, is going to be 1 over the square root of 5, which is going to be less than 1/5. But let's see, square root of 5 is obviously a little bit bigger than 2. So it's a little smaller than 1/2. So if this is 1 and this is 1/2, it's going to be somewhere around there. So our ellipse is going to look something like this. Oh my goodness. Okay, something like that. That's a little messy, but you get the gist. So this first vertice, so our vertices are at plus or minus 1 over square root of 2, or I suppose I should rationalize that. So square root of 2 over 2, comma 0. And then our other vertices, they'll probably only want the ones on our major axis, but our other vertices are 0, comma, plus or minus that. And that's just this rationalized. Now our foci, remember, that's c squared equals a squared minus b squared, where a squared is the square of our major radius, and b squared is the square of our minor radius. So that's going to be c squared equals 1/2 minus 1/5. Ooh. So that's, let's see, 5/10 minus 2/10. So c squared in this case is 3/10. So our foci is going to be on that major axis. It's going to be plus or minus the square root of 3/10, comma 0. Now we need to find that directrix. I don't believe an ellipse has a directrix, or I think that they technically do, but we're going to say D and E does not exist. And of course there are no asymptotes here either, so that does not exist. Next up is number 6. Once again, we're given an equation, and we want to figure out what type of conic section it is, and then find all of those details. This one looks like it's also going to be an ellipse, but it's presented a bit differently, right? This is a different format than we've seen before. So what we want to do is get it to be, we want to get it into that same form like usual. This time it's not centered about origin, it's not in standard position, so we'll need to figure out that center. The first thing that I see here So I've got an x squared minus a 24x, which tells me that I'm going to have x something squared, right? So this is my a value, this is my b value, and then there's some c value that's going to be in there. Not, sorry, that's a little confusing, but like when I have like a squared, or sorry, like ax squared plus bx plus c kind of deal, like or quadratic formulas. But so this tells me that that's going to be x minus 12 squared, right? Because if I FOIL this out, it's going to be x squared minus 24x, but then plus 144. But we don't have a plus 144. We've only got that plus 80. So in order to get that to be plus 80, I need to find the difference there. So it's going to be 144 minus 80 is going to be 64, which tells me that I have x minus 12 squared plus 4y squared minus 64 equals 0. Because once I add that minus 64, this turns into that 80. So now we've got that bit, which is a good start, but nowhere near done just yet. Oops, I erased a little bit my y. Now I want to be able to try and do the same thing with my y, but that seems a little trickier. There are no just y values, right? There's this y squared, but there's no just y, which tells me that I don't have a situation like this where it's something like that squared. Instead, I'm going to go ahead and add 64 to both sides. So it's going to be x minus 12 squared plus 4y squared equals 64. And if you'll remember, the format for our ellipses looks like this. Equals 1. So this is really, really close, but this needs to equal 1. So I'm going to divide both sides by 64. Everything gets divided by 64, which tells me I have x minus 12 squared over 64 plus, well, 4y squared over 64, which is just going to be y squared over 16, because of how that cancels, equals 1. So this is now the same equation, but now it's written in a form that we understand, which tells me that our center, so our center is going to be at 12, 0, which helps us a lot, because if we had just tried to find our vertices, presuming it was at origin, that would be really difficult and incorrect. But now, so that tells me that my x-axis is my major axis, and that my major radius, my a value, is going to be 8. My minor radius is 4, well, plus or minus, of course, which means now, to get my vertices, I'm going to take my major axis, my major radius, I'm going to add or subtract it to that. So it's going to be 12 plus or minus 8, 0. So my vertices are 12 plus 8, that's going to be 20, 0, and of course it's going to be 4, 0. That's probably all it's going to want from me, but I am going to do our minor vertices as well. So now it's going to be that y value plus or minus the minor radius. So it's going to be 12, negative 4, and 12, 4. Okay, so that's all our vertices for this. Next up, we want to find our foci. Remember, c squared equals a squared minus b squared. So c squared equals 64 minus 16, which means c squared equals 48. So our focus is going to be plus or minus a square root of 48. I am going to simplify that a little bit. You know, I can factor out a 16, which is going to be that. Okay, which means my foci are going to be 12 minus 4 square root of 3, 0, and 12 plus 4 square root of 3, comma 0. I believe you can put it in the homework just like that, actually. But feel free to type that into your calculator if you feel like if you want to put in a numeric answer rather than a exact symbolic answer. Again, since this is an ellipse, there's no directrix and no asymptotes, and our axis is our major axis, which again happens to be our x-axis, so y equals 0. Okay. The next questions on this homework are not on our conic sections. This is stuff we should know by now, but always good to review. So we've got some limits here. So they want us to reduce this limit and evaluate it. So the first thing that I see is I can factor out a 7 up top. So it's going to be 7 e to the 3x minus 1 over e to the x minus 1. And remember, I can put that 7 in front of the limit. So it's just 7 times whatever the limit of all of this is. And if we remember those rules, the limit of this is just going to be whatever those are divided by. So it's going to be 7 from here times 3, which is just 21. So that limit equals 21. Next up, they want us to evaluate this limit, which looks a little more intimidating. If you remember, though, we do have a rule for the limit approaching 0 of like sine of something x over x, but this also has a cosine of x. So what we want to do is we want to split this up into two limits. So I'm going to split it into the limit approaching 0 of sine of 4x over x times the limit approaching 0 of cosine of 12x. Now, I know that this limit from our rules is going to be that quotient, so it's going to be 4 times, well, this limit, and I can plug in that 0. Cosine of 12, 0 is just 1, so 4 times 1, or just 4. Next, they tell us that if f of x equals 4t squared plus 4 over t to the 5th, what is the derivative of f of x? So f prime of x. Well, first I can do that power rule, so it's going to be 8t. And then this is also power rule, but remember this is t to the negative 5th. So I'm going to multiply by negative 5, so I'm going to get minus 20. And I'm going to subtract 1 from the exponent, so it's going to be, instead of t to the negative 5th, it's going to be t to the negative 6th, or in the denominator, t to the 6th. Next up, we say that m equals secant x over x to the 5th. You want to find the derivative of m with respect to x. So in this case, I would apply that quotient rule. So we know low d high minus high d low over low low. So we'll take that low term, so it's x to the 5th, times the derivative of my high term, which is secant x tangent x, minus my high term times the derivative of my low term, all over low low. Now I see I can factor out an x to the 4th. So I'm going to factor that out. It's going to be x secant x tangent x minus secant x all over x to the 10th, and I can cancel that. So I'm just going to get x secant x times tangent x all over, that's going to be x to the 6th. Oops, nope, I forgot that additional, whoopsie, forgot to subtract that extra secant x. There we go, now over x to the 6th. Now, slightly trickier one, says the natural log of x plus 3y equals x to the 6th. We want to use implicit differentiation to figure out what dy dx is. So remember that the derivative with respect to x of natural log of x is going to be the derivative of the interior over the interior itself. So the derivative, so we have to first take the derivative of x plus 3y, which is just going to be 1 plus 3 dy dx. So the derivative of this is going to be 1 plus 3 dy dx over x plus 3y. And that's going to equal the derivative of this, which is 6x to the 5th. And now we just have to manipulate this to get dy dx by itself. So first I'm going to multiply both sides by this denominator. So it's going to be 1 plus 3 dy dx equals 6x to the 5th times x plus 3y. And I am going to distribute that actually. So it's going to be 6x to the 6th plus 18x to the 5th y. And then subtract 1 from both sides. And then, to get dy dx all by itself, we just divide it all by 3. Which is going to be 2x to the 6th plus 6x to the 5th y minus 1/3. So that is our derivative. Number 12 is similar, but not as difficult actually, because there's not that natural log. So we first want to use implicit differentiation and find dy dx. So if x squared plus y squared equals 34y, I'm going to take the derivative with respect to x. So it's going to be 2x plus 2y dy dx equals 34 dy dx. And this might look confusing just because we've got two dy dx's, but that's not a big deal. We just want to put them on the same side. So I'm going to subtract this from both sides so that I've got all my dy dx's on the same side. And now 2x equals, and I'm going to factor out the dy dx. So dy dx 34 minus 2y. Now to get dy dx by itself, it's really simple. We just divide both sides by this. So dy dx equals 2x divided by 34 minus 2y. And I see I can factor out a 2, so I'm just going to do x over 17 minus y. And now using that, we want to find the equation of the line L tangent to this function at the point 8, 2. So of course we want to find our slope, which is going to be this at that point. So plugging in an 8 for my x and a 2 for my y, I'm going to get a slope of 8/15. And easiest way to do this, in my opinion, is just to use point slope form instead of trying to make it slope intercept form, because I can just do y minus the y value equals the slope times x minus that x value. And boom, there it is. If you do want to do slope intercept form for whatever reason, so that's of course our y equals mx plus b, you could do y equals 8/15 x plus b, and then of course plug in those values to solve from there. So it would be 2 equals 8/15 times 8 plus b, and then you just have to solve for that b value, of course. So it's 2 equals 64/5 plus b. So 2 minus 64/5 equals b. Sorry, 15ths, not fifths. Ooh, careful. Easy mistake to make. And that's going to be, so that's essentially 2 minus 4 and 4/15. So it's going to be negative 2 and 4/15 equals b. So then you would have an equation of y equals 8/15 x minus 2 and 4/15. Or you could write that as minus 34/15. Again, personally, I prefer point slope form, because it's just easier to, it takes less time and it's easier to type in to the homework, in my opinion. But to whatever works for you. I just find that there's a lot more room for error when you try to put it into slope-intercept form. But that is the last question for this homework. Sorry for getting this one out to you guys so late. It's been it's end of semester, so I've been kind of busy with a lot of assignments. But we are nearing the end. I hope that this video was helpful, and thank you for watching.